In this video, we're going to look at using critical value tables to tell if the results of an experiment are significant or not. And the key thing here is if you don't get it and you tried the example at the end of the video and you still don't understand it, then this is something we're going to go over a lot in class. So don't worry too much. As long as you've got the notes down and can refer to them in the lesson when you're stuck, then that's fine. So there's a number of steps we're going to run through. The first one you've got to know is knowing the hypothesis. And this is really important. And you'll get to see why when we look at some of the tables. But if a directional hypothesis is being used, we always use something known as a one-tailed test for statistics. And if a non-directional hypothesis has been used, or you've been asked to write a non-directional hypothesis, then we always use a two-tailed test. So directional, one-tailed, non-directional, two-tailed. So if we look in here, this is something that you're going to get. So a psychologist was also interested in the effects of a restricted diet on memory functioning and expected memory to become impaired. The psychologist's hypothesis was that participant scores on a memory test are lower after a restricted diet than before a restricted diet. So you've got to be able to pick out the hypothesis. You see here, the hypothesis was that participant scores on memory tests are lower. So it's a directional hypothesis. He's stating it's going to go in a certain way. They're going to lower after a restricted diet. So you usually get this little bit of blurb about an experiment. And they'll also give you a calculated value. So here it says the calculated value from the experiment, once they've done the Wilcoxon's test, was t equals 53. So they'll always give you a calculated value. And that calculated value is what they get after they put the data through a significant or statistical test. So then you're going to get one of these tables, and they're going to ask you to work out whether the results are significant or not. And you've got to be able to tell just from looking at this table and the data they've given you, is it significant or not? Right, we already know that we're using the one-tailed test, so we highlight that little part along there where it says one-tailed test. Then you've got to start thinking about what p-value do you use. If you remember from previous videos, we always said that you use a certain probability value. We always use p less than 0.05, unless they tell you otherwise. If they tell you to use a different one, use that. But if they don't tell you, always use 0.05. Remember, that means that the likelihood that the results were down to chance is 5%. So we're going to be 95% certain of our results. So we've got our table again. And now we know we're using this column here. We already know that we're using the one-tailed test because it was a directional hypothesis, and we're using 0.05. So we're down this column here, okay, because that's 0.05. Right, next, you need to know how many subjects there are in the experiment. So they'll always tell you how many subjects there are, and sometimes they might use a word like the degrees of freedom instead. So they'll either give you the number of participants or they'll give you the degrees of freedom in the experiment. That's what you've got to know. So in our experiment, which was mentioned at the start, we know we're using 0.05, and it also said that there were 20 people in the experiment. So where they cross over, we get something called the critical value. That critical value in this case is 60. Okay, so we've got given the calculated value at the start, which was calculated from the statistical test, and we've also now got a critical value. This is called the critical value table. It says it at the very top here. So our critical value is 60. The next thing you've got to do is read the line at the bottom of the table, and that's really, really important. And here it says the calculated t must be equal to or less than the critical value for significance at the level shown. Okay, so the key thing you've got to take away here is the calculated value must be equal to or less than the critical value. That's the key thing you need to take away from this. And it might be different on every single table they give you, so you've got to make sure you read it. So how do we write up our answer? So it's asking you, it's giving you that experiment. It says, right, using the critical value table, are the results significant or not? So we would say that the result is significant because the calculated value that they gave us at the start of t equals 53 is less than the critical value of 60. So remember at the bottom of that table that we just looked at, it told us that the calculated value, if the calculated value is less than the critical value, the results are significant. So in this case, the calculated value of 53 is less than the critical value of 60. And then you give them the information back that they've already given you, where n equals 20, so the number of people in the experiment is 20, and give them the probability value that you used. And p is less than 0.05 for a one-tailed test. So you'd structure it just like that. Results are significant because when. Okay, so using those bits. Right, in your exam book, have a little go at January 2013, question 22 in there. And there are going to be lots of these in the past assessment papers or past assessment papers that I've given you. We'll be going through a lot of them in class. So if you didn't have a clue what just happened, as long as you've got this information written down, we'll go through it far slower using loads of different examples in class.